So we have seen this G. Huyu G inaonekana ana vary na vitu vingi. So G kama G, value of G varies with four things, at least four things. It varies with altitude, it means the distance from the surface of the earth. It varies with depth, it means the distance from the center of the earth inside the earth. It varies with the rotation of the earth, okay? It varies with shape of the earth. And before we proceed, let us see the following. So we are seeing here that the value of acceleration due to gravity varies as we go below, above the surface, okay, surface of the earth. It also varies from place to place on the surface of the earth, and that's where the rotation and the shape of the earth comes in. So let us start with variation with altitude. It means altitude, the distance from the surface of the earth going into the air. So the altitude h, okay, the height from the surface of the earth. So consider the earth to be a sphere of radius r, okay. The earth to be a sphere of radius r, as we have seen here, it is a sphere of radius r, and the body is at a point P, distance h plus r, okay. The distance, total distance from the center, itakuwa ni radius of the earth plus height h, which is the altitude we are talking about. So consider this to be a sphere of mass m, the acceleration due to gravity on the surface of the earth, point Q. Okay, so they are using point Q whatsoever, point Q, okay. Acceleration due to gravity on the surface of the earth, it means point Q. Point Q ni kwenye surface of the earth, but that body is at point P, somewhere where we are trying to see the difference between ikiwa kwenye surface of the earth na ikiwa at a certain height. It means that's where the altitude is coming in. So ikiwa kwenye surface of the earth, G ni sawasawa na G times m over r squared. Ikiwa kwenye surface of the earth, as we have seen in the previous questions, maswali tuliyotoka kusolve previously. But consider a point P at a height h above. So the distance now, what is changing is only this distance. Ikiwa kwenye surface of the earth, okay, ikiwa kwenye surface of the earth, distance from the center ni r. Ikiwa at a point P somewhere high in the sky, inakuwa height h plus r. So what is changing is just this, but this time ni height h plus r. So we have two equations. So if we divide the two equations, that G at a certain height divided by G at the earth surface, okay, ni sawasawa na gm. So if we divide gm na gm zitapotea, okay. So tutabaki na r squared u divided by r squared plus h chini if we divide the two equations. So what are we seeing here is that we are seeing that this G varies inverse proportional to the square of the distance from the center of the cycle outside the earth, okay, outside the earth. It is important to know that because we are going to see kuna different variation when the body is varying distance inside the earth. So our point here was trying to relate the gravitational, the acceleration to gravity or the field strength at a certain height h. How does it vary with that h? As we can see, r is constant. So basically it varies with the square of the distance from the center of the earth if it is outside the earth. Therefore, gh ni sawasawa na r squared divided by r plus h times g squared times g at the surface of the earth. Okay, if and therefore gh will always be less than g. So this tells us the farther we are going away from the earth, okay, the farther we are going away from the earth, the smaller the gravity is becoming. Remember, you are going up, you're going up. So h is increasing. If this denominator is increasing, it means this value gets smaller and smaller and smaller. So when it is multiplied to g, inaendelea kuipunguza tu ile g. So it means the far we are going from the center of the earth, outside the earth, the less the gravity is becoming. And that's why from this space in the other planets, watu wanakuwa wanaelea because g is almost negligible. Sometimes it decreases to very low values. So I just want you to note this. It is so far good and enough, this formula. So this is how they relate here. So if we come to variation of G with depth, now inside the F, kumbuka the F inakuwa ina vary volume kulingana na the sphere inside the cycle. What I mean ni kwamba if this, I assume for this case tutakuja kuona just my assumption for now, that assume this is the F, mwanzo uko hapa, okay? It means unapoingia ndani ya dunia, mwanzo ikiwa hapa, tunakumbuka hii ni sphere, our assumption is the Earth is sphere, so 4/3 pi r cubed. So ikiwa kwenye radius hapa, kwenye Earth surface, the radius is the radius of the Earth, right? Yes, the radius is the radius of the Earth. So tunakuwa na 4/3 pi r cubed. Okay, so inakuwa ni volume yake. Tukiingia ndani, distance d from the surface of the Earth inside the Earth, tutakuwa tuna another sphere. The sphere will be, tunaoongelea ni hii hapa, ambayo sio tena r, ni r minus ile d ambayo tumeingia ndani. So tunaona volume inabadilika, the mass inabadilika, and it affects everything, as we shall see how G varies with the distance inside the Earth, which in other words we call it the depth. So the height and the depth inside the Earth. So we know that when the surface of the Earth, we start with when the surface of the Earth, G is sana, gm over r square, where r is the radius of the Earth. So if density of the Earth is given by mass over volume, and we know that mass is given by density times volume, and we know so the mass is given by 4/3 pi r cubed times density. So hiyo ikiwa kwenye Earth surface. So if we are going to substitute the mass here, okay, if we are going to substitute the mass here, it means we will have G is equal to 4/3 pi r density times G. Kumbuka we substitute pi r cubed, and inakutana na hii r squared na r cubed kinakufa, inabaki r moja. So it's just simple. Chukua hii mass, itumbukize hapa, substitute hii mass, weka hapa 4/3 pi r cubed times density. Utakuja kupata kwamba, so tena uzuri ni kwamba amekurahisishia hapa. So here we have G over r squared, mass ni 4/3 pi r cubed times density. So r squared na r squared zinakufa, inabaki r moja hapa. So you have G, okay, 4/3 iko hapo, pi r imebaki moja times density. So hiyo ni kesi yetu ya kwanza, ikiwa kwenye surface of the Earth. Assume a point P, again kama mwanzo point P ilikuwa high in the sky. This point P this time is deep into the Earth. So point P is there, distance d from the surface of the Earth. Okay, so what we'll be having ni kwamba we have gravity at that point D inside the Earth is equal to G times mass of the Earth now with the compressed volume. Kumbuka volume imepungua, so the mass is changing, the density is constant, the volume may change, the mass will change. So m dash, mass of that sphere where the new point is, divided by the distance from the center of the cycle. So distance from the center of the Earth is no longer r, because the body is no longer the surface, but at point P, which is r si yote minus d, hii distance hapa. So unapata hii tu ya ndani, so ni r minus d squared. So again we know that mass is given by 4/3 pi, the radius cubed. Now the radius now is r minus d, because that's the sphere we are speaking of, the inside sphere. So r minus d cubed times density. So if we substitute kwenye our formula here, so tutakuwa na G over r minus d squared, em ndo tuna substitute 4/3 pi r minus d cubed times density. So r minus d squared na r minus d cubed zina cancel, unabaki na r minus d hapo juu. So we have 4/3 pi r minus d density times G hapa. So again if we divide GD, okay, divide by, kama tulivyofanya mwanzo, divide by G kwenye Earth surface, so tunakuwa na just try to divide yourself. Utaona zina cancel, unabaki na r minus d divided by r. And therefore, if we look kwamba GD, how does it vary na depth D inside, tofauti na mwanzo, utaona this time zinakuwa ni they are direct proportional. Okay, zote ziko juu. Ile ya kule ilikuwa moja iko juu, moja iko huku chini. So ukiona hivyo unajua ni inverse proportional. Lakini kwa hapa unaona GD na D ziko in one side, it means they are direct proportional. So what I want you to note ni formula kwamba GD over G ni sawa na R minus D over R. Just remember, huku ni direct proportional, kule ni inverse proportional, lakini pia ni exponential function. Unaona hapa hamna squares. So as far as variation with depth is concerned, hapo inakuwa imeishia hivi. So again, we have variation with the rotation of the earth. We know the earth is rotating. Okay, it is revolving around the earth. It is rotating within its own axis. Okay, so basically maelezo ya hapa ni mengi kidogo na they are a little bit very mathematical. So as my students, I wouldn't want you to get into trouble na kupanic na kufanya nini ya understand all this part. Unaweza ukatafuta S-chance ukaenda ukaangalia if you are interested. But as my student, the only thing I want you to know kuhusu rotation of the earth, that eventually tunakuja kupata this formula here. It's the only thing ambayo mimi nataka ukariri. And it's the only thing I want you to understand and know kwamba G dash ni sawa na G minus R W squared cos squared hiyo angle lambda. So G is the gravity at that point on the earth where kuna varying rotation. And G is the point, is the normal gravitational force kwenye surface of the earth, just normal. Okay? Minus R is the radius of the earth. W squared is the angular velocity at that point ambayo umeweka. Na cos squared lambda, the angle is the cosine of the angle that is extended. Okay, the angle that is extended by the body kwa kuwa that point. How is this? So we are having a complex diagram here. So we have at that point kwa mfano, we have at the poles, we have at the equator. Both angles zinazokuwa distended, they are different. So inapokuwa hapa, the body inapokuwa hapa is different. The body inapokuwa kwenye poles is different. So ikiwa kwenye poles, the angle that is being distended, angle lambda. Kwa mfano ikiwa that point, as you can see. Okay, as you can see, mshale unavyoonyesha this angle lambda. Ikiwa the equator, assume this point P iko hapa at E, utaona the angle is 0. Okay, na ikiwa at the poles, kwenye poles utaona this angle is 90. If you take this ukaipeleka kwenye poles, hii angle itakuwa ni 90. Ukichukua hiyo P ukaipeleka kwenye equator, hiyo angle itakuwa ni 0. These are very two important things I want you to understand. Now that's the angle they are meaning hapa. So if it is at the equator, as you have said, the angle is 0. So we know cosine ya 0 ni 1. So basically, ikiwa kwenye equator, the formula becomes this. Ikiwa kwenye poles, the angle is 90. So cosine ya 90 ni 0. So ikiwa kwenye poles, G ni sawa na G. So it means G becomes maximum when in the poles. Okay, when in the poles, G becomes maximum. So even vitu viwili tu ambavyo nataka ufahamu. Kwanza, the general formula. Okay. Second, kwenye equator, it means the angle is 0. So cos ya 0 ni 1. So unabaki na G minus R W squared. Na kwenye poles where the angle is 90. So G inakuwa ni G na inakuwa maximum. So the G is maximum kwenye poles. There are a lot of mathematical details and I wouldn't want you to get into that trouble. There is one imebaki, variation with shape. We are going to see it. Tunarudi kwenye our normal lesson notes ambazo tumeziandaa and we shall see the variation with the shape. So variation with the shape of the earth, the concept is just the same. Tofauti na ilivyo variation ya kwenye rotation, as we said, the angle ikiwa kwenye poles ni 90 na ikiwa kwenye equator ni hiyo. Variation with the shape, as you can see, tunaweza tukatumia mfano when the body is there, there is radius E. Okay, the body ikiwa kule, the radius is different. Distance ya kutoka hapa mpaka hapa na hapa mpaka hapa is different. Unajua the earth is not a cycle, it is a sphere. So a sphere varies with the radius depending on the position. So RP na RE basically hakuna tofauti na variation ya shape na variation ya altitude. It's just basically the same. As usual tulivyokuwa tunafanya, tutaanza kwa kusema G ikiwa kwenye surface. Sasa ikiwa tuseme at point ya equator hapo, distance RE, so itakuwa ni G m over RE squared, na ikiwa kwenye point ya pole itakuwa ni G m radius ya pole squared. So basically it won't change anything. So G over G ya kwenye pole, if we divide them, G cancel, so kutakuwa na RP squared huku na R squared huku. So we shall see kwamba gravitation as shape of the earth itakuwa ina vary inverse proportional na exponential wise, just like the way ilivyokuwa kwenye altitude. So haina tofauti. And this is the graph that summarizes what we have been saying, that inside the earth. Previously nilisha kuonyesha this graph kwamba G varies G dash inside the earth is direct proportional, okay, is direct proportional to the R, which is the distance from the center of the cycle, the depth inside the earth. While outside the earth, G, okay, varies inversely, okay, and it's an exponential function because of the square outside the earth. This is inside the earth, assumes a uniform density.